Okay, you got 20 minutes. I'll let you know at 5:15.
Okay. Thank you very much. This is an honor to be here in this series of Congress. We are working on nanomedicine. So I talk about brain and spinal cord and some other diseases and try to use some nanomedicine application in some kinds of human diseases. We are working with the US Air Force Research Laboratory, Department of Defense, Swedish Society of Academic Research, European Office of Aerospace Research and Development, National Center of Toxicological Research, Human Health Sector of US Air Force, Swedish government, and I am from Uppsala University. This is a multi-organization collaboration, and our idea is to develop nanomedicine to treat central nervous system injury in laboratory. Whatever I am expressing here, this is not the organizational view, this is my personal view. This takes time. Okay, the idea is we started on nano wiring of some medicine to have better effect in central nervous system since 2004, and the story is still continuing. So I will talk about today brain, and as you have seen, Alzheimer disease, there is no cure. But there is no cure of any disease so far we know, like cancer and any other disease. Even millions of dollars are spent every year. Why we talk about nanomedicine? I mean, to this audience, I mean, this is not new. I can only tell that there are many factors to be known because, for example, size, type, and also their modulation by disease or environmental factors. I am involved in blood-brain barrier because this is the key regulator in the brain for all kinds of disease. For example, if my blood-brain barrier is supposed to be normal, I may not have any brain disease. But all kinds of disease afflicting brain or even liver and kidney influence the blood-brain barrier, increases permeability to proteins. I did a thesis on stress and blood-brain barrier long ago, and that opens my brain as well to do some research how people in different diseases they have blood-brain barrier open and how can we protect them. People are talking in the brain there are three parts. Neurons that we believe is main component of the brain, but they are still in minority, and we have much more glial cells that surrounds the neurons and also the endothelial cells. My talk is largely focused on endothelial cells. The point is that still we can regulate this endothelial cell function with drugs and modulate by different kinds of nanoparticles. The anatomical site of blood-brain barrier is the tight junctions between the two endothelial cells as well as the cell membrane, that is protein-lipid protein membrane, that regulates our brain function. I am basically pathologist, neuropathologist. So I want to see the changes by light and electron microscopy in the brain when we treat with nanomedicine, whether we have any benefit or not. We and my wife worked with Dr. Sharma from Germany. He is one of the leading professor of electron microscopy. I have the honor to work with him. So we believe that any kind of insult to the central nervous system opens the barrier, and there are many other pathways leading to cell death. So my point is, or our point is, to reduce the cell death. If not, we can prevent it. We have highlighted the importance of blood-brain barrier in some of the publications, prestigious publications by academic press. And also we work with Dr. William Slicker, US FDA, because the point is that nanomedicines as a medicine are still not regulated by FDA, and they are preparing the guidelines how we can use in humans. To highlight the importance of nanomedicine and nanoneuropharmacology, we did some volumes earlier and also discussed with Nobel laureate Aaron Chickanover. I will briefly show you some of our experiments with Alzheimer disease using nanomedicine. As you can see that over 5 million Americans are exposed to this kind of disease, and still we have no cure. The paper we had just published in molecular neurobiology recently. This is very old picture, and a German doctor, Alzheimer, diagnosed this type of disease first time, and that's why the disease carries his name. Since you are from different background, I can just show you some of the examples that when we have Alzheimer, our brain will be like this as compared to the normal situation. So it is devastating changes in many parts of the brain. The point is that how we can restore or minimize the dysfunction. If you look at light microscopy, the brain is filled with many senile gates, and that is the result in Alzheimer cases. This was the staining of amyloid beta peptide. Some of you might be knowing that this is the crucial protein that deposited in the brain. The question is other thing, that whether its exclusion is prevented in disease or it is more deposition in the brain that leads to Alzheimer. These are cartoons showing that Alzheimer, this amyloid beta peptide can be broken into tau protein, and the phosphorylation of tau is one of the important aspects, and both are dangerous. This is a cartoon showing the enzymes are clean. This cartoon I just show that previously people think that we have to prevent neurons. But now many people know that neurons are in minority. We have to also restore glial cells, and most importantly, the endothelial cells. Here, there are a few examples I'm showing that even some times ago, 5 years ago, people were not thinking that blood-brain barrier is the key factor in Alzheimer disease. I summarize some of the literatures. Some of the human cases, you can see that with Alzheimer disease, all are vascular changes. There are many enzymes in the endothelial cells that regulate the function, and all these enzymes are also altered. A list is there. This time is short, I can show. Some of the examples showing that really the endothelial cells are damaged in Alzheimer disease, and that makes our story interesting. There are many points of view to treat Alzheimer using drugs, antibodies, and also some latest development. Recently, neurotrophic factors were supposed to do some better in Alzheimer disease. Some of the examples are given here. Nanotechnology comes late in Alzheimer disease, but it is picking up, and there are many papers now trying to use nanotechnology to reduce the pathology of Alzheimer disease. We came across a drug called cerebrolizine, and manufactured in Austria, and there are certain clinical trials in stroke, traumatic injury, and even Alzheimer disease are going on in the United States of America, so this is FDA approved. It is multimodal drug. The point is that if we have disease, there should be no single factor. It is the combination of different type of factors that modulate. In our body, even we have some natural neuroprotective agents, but also we have neurodestructive agents. So the balance is the main important point. So as you can see here, we tested this drug in different type of models, and it works in our hand. This is the first picture when we have shown that, of course, in animal model, that the albumin leakage in Alzheimer disease, and that was reduced by cerebrolizine. Then we are using nanowires. Nanowires, the inventor of nanowires is Dr. Young, but he did for electronics, but we are using them in medicine. These are the nanowires, titanium nanowires. At the moment we are studying because they are mostly innocuous in medicine. This is Dr. Ryan Tian, and this is Dr. Wang. They have the US patent of nanowire material, and we use their technology to label drugs. Nowadays, even stem cells are nanowired, and these are just an example. They are much better, they are much longer surviving, and we have nanowire technology is very expensive. We have support from also politicians. This is previous Arkansas governor from Democrat, but there is no political agenda here. And when we submitted our first nanotechnology induced prevention of some kind of brain injury, to National Innovation Summit and Showcase. It occurs every year, this year also in Anaheim in May. We were surprised that we got top 15% technology award. My wife actually got it for this. You can see this. And this was the award. So we are enthused. And also we received earlier as well, different years, so we are lucky. So now, the point is that in Alzheimer's disease, amyloid beta peptide deposition in the brain, can we reduce it? And the answer is yes. If we give nanowire cerebrolizin, the reduction is much more evident than cerebrolizin. The idea is nano delivery of drug can enhance the superior function of the drug if the drug is good. But nano delivery cannot make a bad drug to good drug. This is an example we measured, and you can see that, sorry. You can see here that amyloid beta we measured in CSF, and you can see that nanowire delivery of cerebrolizin reduced the maximum. The second thing happened with tau, and also the nanowire cerebrolizin is much better than cerebrolizin alone. So we use this model to study pathology in Alzheimer's disease and trying those things. And the second part is that if you use naive rats or, inject the same thing, but if you have previous conditions like traumatic brain injury or any kind of depression or hypertension, the drug is not acting in that way. I'm showing you an example. I believe in the neuropathology anyway. So this is the amyloid beta peptide here, infusion-induced deposit. And this is nanowire cerebrolizin. And this is the albumin that is not showing very much when we have given nanowire cerebrolizin as compared to cerebrolizin. Then you can see here that we have also used nanowire cerebrolizin, and gliosis, astrocytes, are much more reduced here, and also the neuronal damages were much less evident. Then we went to study at electron microscopy. And also we see here that only amyloid beta peptide infusion, myelin degeneration, and the much clearer preservation of myelin as compared to cerebrolizin alone. So the point is that cerebrolizin, if given nanowire delivery, is preventing much better than the drug alone. It can be also true with other drugs. So the point is that if we have other disease like hypertension, diabetes that is quite common in humans, can it affect? And you can see here that these are infusion in diabetes. They are much more higher, and nanowire cerebrolizin is able to reduce that. Normal cerebrolizin given an identical dose was not able to reduce. Then some other example, antibodies. We have identified some antibodies, and they delivered using titanium dioxide nanowire. My time is short, so I'm just skipping some things, but I told you that nanotechnology for Alzheimer's disease is quite interesting nowadays. And I'm just skipping. I want to show you just that amyloid beta peptide infusion. It is the CSF level, cerebral cortex, hippocampus, and cerebellum. When we have used another model, PLGA level cerebrolizin, it also reduced. But I can tell you that titanium dioxide nanowire level, the same drug in same dose, is much more effective than the other way. So my point is, the delivery of drugs is also important. Here you can see that nanowire cerebrolizin is reducing much better. These are the example of temporal cortex pathology after injecting antibodies to tau with nanowire cerebrolizin. This is another example, and I just skip that. Stress can also influence these things, and I'm just showing that depressive stress when given with nanowire cerebrolizin is better preventing. This is another example of PLGA. Hypertension, I'm just showing you one thing heavy. Yes. When we combine the nanowire delivery of cerebrolizin with other neuroprotective agents like mesenchymal stem cells, we have superior neuroprotection. You can see here in this example here. And neprilysin, for that my wife got the award. we have injected nanowire nebulizing together with cerebellizing. We have much better effect after head injury. And these are the example here. These are the example here. You can see that cerebellizing has much more better. Hippocampus protection is also much better here after traumatic brain injury. And I show you PLGA. When we label the drugs with nanowire technology, they can have much longer in the blood and have better effect. This example I am showing that this is TiO2 cerebellizing therapy and PLGA cerebellizing therapy. All were better, but this nanowire delivery is much superior than the PLGA. Now we are testing with detonate nanosphere, injecting cerebellizing or any drug here in this hollow shaped material, and you can see that we can have higher sustained release. We believe that nanowire drug can penetrate the cell membrane without damaging it. They can release their content here and also protecting the brain for a long time. Now we are also working with other Nobel laureate, Sharma, regarding antibiotic resistance. So the idea is that if we use them using nanotechnology, can be prevent somehow antibiotic resistance. And we have just produced this book from Springer, and Springer Nature representative is here. So you will be pleased to know Ms. Mary Stewart was my contact person recently, and the other from a senior academic press, nanomedicine and CNS injury. And now we are working with some other Chinese government. These were some highlights in SFM last year. They came in hot topics. And this year we are also lucky that one of our innovation got Global Technology Award. There were 11 awards given out of 150 innovations submitted. So we think that we are going in the right direction. These are our sponsors, collaborators, friends, and Yomotsura University. And thank you very much for your time.
We have time for questions. If anybody has a question for him. Anybody?
Yeah. One. I'm just curious, how do you deliver nanowires? Like, how are they combined with the drug, and how do they reach the quantity?
Yeah, we have tested also topical application. We have also applied intravenously. We have also given intraperitoneal, and over the time we measured drug concentration in different levels, also in the brain. They are much more higher in the brain and plasma as compared to the normal drug. So we believe that it is going fast into the brain, penetrating the cell membranes and entering the brain to the microplasma and releasing the drug by many as much as pump for long time. That would be one question.
Okay. Any other questions, please? Right there, sir.
What other nanowires show
Well, that's a good question. Other people are using copper nanowire, silver nanowire, and even aluminum nanowire. But at the moment, we are using titanium nanowire because of some technical and legal restrictions. And we have injected only titanium nanowire in animals for 6 months, and we cannot see any clear brain injury for that period. We have no permission to go beyond that.
So it has less chance of oxidizing compared to the others that you're talking about also.
Yeah, this is a possibility. Yeah.
Thank you.
Okay. Final questions, sir, folks? All right, give them a round of applause. That's my Texas accent.